Okay, welcome back. In this video, it's all about measuring concentration and solving concentration problems, specifically with molarity, which is by far the most widely used measurement of concentration. This first problem in front of you is probably the more basic and easiest one of them all. A solution of hydrofluoric acid is made up of 4.5 moles of HF and 23 liters of solvent. What is the molarity of the solution? All you need to think back to is what is the definition of molarity, the mathematical definition of molarity. Molarity, which is the big M, is equal to the moles of the solute divided by the liters of the solvent. Okay? Usually the solvent is water. In this case, the solute is going to be the HF. Well, it gave us that we have 4.5 moles of HF. Okay? So I'd like to write down our knowns here that the moles are equal to 4.5 and that the liters are equal to 23. So we can plug that into the formula. We have 24 moles, 4.5 moles over 23 liters. And now this is just a basic division problem, ladies and gents. 4.5 divided by 23. That's going to come out to two significant figures with 0.20 moles per liter. That's one way you can write this, or you can collapse the moles per liter down into the big M. Okay, either one of these is correct, okay, because MOL, mole over liter, is the same thing as the big M, mathematically. Alright, let's look at another problem. This one's going to be a little bit more complicated. This time it says you have 32 grams of strontium iodide dissolved in 110 liters of water. What is the molarity of the resulting solution? Alright, think back to the definition of molarity. Big M is moles per liter. So we need to figure out what are the moles, okay? Did it give us moles in the problem? Oops, it did not, okay? It gave us grams, so I guess you can already guess what we're going to have to do. Did it give us liters? It did. It gave us 110 liters. So before we can solve this, ladies and gents, we've got to get those 32 grams of strontium iodide into moles. Now, this problem was kind, and it gave you that the molar mass of strontium iodide is 341.42 grams per mole. Let's go ahead and solve that. Okay, so we have SRI2, we've got 32 grams of it, and we need to convert those grams to moles using the molar mass, 341.42. Continuing the work right down below, that's going to be 32 divided by 341.42, and we get two significant figures, so 0.094 moles. Right. Now we're ready to plug this into the definition of molarity. Okay, 0.094 moles divided by the 110 liters, and this should give us our molarity. So 0.094 divided by 110. It's going to come out to be a really small number. We get only two significant figures because this last zero is not significant. 0.00085 moles per liter, or you can also write it as 0.00085 with a big M. Okay, either one of these works. Don't write both of them on the AP exam, just choose one of them. Choose whichever one's your favorite. I typically like to leave it in the broken down form. Alright, let's look at this next example. What is the molarity of 320 milliliters solution with 0.211 moles of sodium fluoride NaF? Okay. Well, it wants the molarity. That's what the question's asking for, and you know that mathematically molarity is equal to moles per liter. Alright, well, let's write down what we know. We do have the moles. That's equal to 0.211 moles Do we have liters? No, we don't have liters. What did it give us? It gave us milliliters. So guess what you're going to have to do, ladies and gents? Convert those milliliters over to liters. So that's where your chemistry, your AP Chemistry reference packet comes into play. You want to go ahead and turn over to the page that says metric units. Okay? And this was also in your summer assignment as well. So to convert 320 milliliters to liters, you need to understand that the bigger unit is liters. Okay? So we're going to set liters equal to 1. And if you look at your metric unit sheet, you should see that 1 milli of anything is going to be 1,000. Okay? So for every 1 liter, there is 1,000 milliliters. That's our conversion factor. So we'll take 320 milliliters, multiply it by the conversion factor. Milliliters on bottom, liters on top, because that's what we're going to. We know that the liters are equal to 1, and the milliliters are equal to 1,000, okay? Because there are 1,000 milliliters to 1 liter. When we divide this out, we will get that there are 0.320 liters, because dividing by 1,000 is the same thing as moving the decimal place over 3. Or you can plug it into your calculator and you'll get the same thing. Alright, we know our moles and we know our liters. Let's plug it into molarity. 0.211 moles divided by 0.320 liters. And we get only 2 significant figures because this last zero, we get 3 significant figures. This last zero is significant because there's a decimal there. Okay, so to 3 significant figures, 0.659 moles per liter, or you can write it as 0.659 big M, which means molar. Alright. You gotta remember how to do those unit conversions down there, ladies and gents. Absolutely essential that you know how to convert between units. Here is our final example. If a 2.0 molar beryllium chloride solution contains 3.8 moles, what volume does the solution occupy? So think about this, ladies and gents. Is it asking us for molarity this time? It is not. It actually already gave us the molarity right here. And then it gave us the moles. The question portion is, what volume does this solution occupy? So it wants volume. Well, which one of these 3 variables right here represents volume? It's the liters, okay? We're actually looking for the liters this time. So we're going to need to use algebra to manipulate this whole equation here before we plug anything in. Let's go ahead and do that. We want to get the L by itself, all right? So the best way to do that is, well, it's on bottom and it needs to be on top first. So what am I going to do to that side? I'm going to flip it. Literally flip it. If I flip that side, what must I do to the other side? I have to flip that one as well. This is technically over 1, so if we flip it, it's now 1 over big M. The L is still not by itself. I can get it there, though, if I multiply both sides by mole. Okay, because this is technically being divided right here, and the way that we undo division is by multiplication, so we do that to both sides. These will cancel. And liters is now mole over big M, or we can rewrite it as liters is equal to mole over M. In AP Chemistry, I assume that you know how to do algebra by now. Okay. So that's our formula. Let's go ahead and see what we know. We know that our moles are equal to 3.8 moles. We know that the big M, the molarity, is 2.0. So now let's just plug it in. Liters, this should be big M, or 2.0 moles per liter. Okay, this is one of those situations where you want to break down the big M into moles per liter. Alright, the moles, 3.8, that goes on top. And on bottom we have 2.0 moles per liter. Guess what? Those moles cancel, and then by division this L will move up top. And if we do 3.8 divided by 2.0, we will get 1.9 liters of solution. Right? Okay, ladies and gents, the AP Chemistry is starting to get a little bit more complicated with the advanced equations. Please go ahead and work through the sample problems, and we'll see you back for dilutions.